Hi, if you're here and you're watching this video, that means that you're looking for some AP Computer Science A-Prep. If you don't already know me, my name is Aditya Anandan. I'm a senior at Irvington High School in Fremont, California. Last year, I took the AP CSA exam digitally and I got a 5. So I think I have a pretty good understanding of what it takes to get a 5 on the exam and how you should prepare and what content you need to prepare. If you're on my YouTube channel, make sure to go check out my Thinkific course. We have practice quizzes, we have worksheets, we have practice tests, and we have these conceptual overview videos that you're going to be watching. We also have some breakdowns on MCQs and FRQs that are going to be really helpful for how to think through problems and how exactly to solve them. So without further ado, let's get to the lesson. Okay, so let's get started with Unit 4, which is inheritance and polymorphism. So inheritance is a pretty simple concept. The AP Java curriculum makes it seem a little bit harder than it actually is. It's just going to build upon the concepts that we learned in Unit 4, which is just classes. So it's just a little bit more difficult version of classes. Alright, so chances are you won't see much of inheritance on the AP test. It's a topic that's not covered as much, but if you are to see a problem, whether on the MCQ or the FRQ section, it's good to know the basics so you can solve it, right? So the first topic that we're gonna do is inheritance, which is pretty simple. We got two types of classes, all right? We got a superclass and then we got a subclass. Okay, so a subclass essentially is just an increased specialization of the superclass. So an example would be a superclass would be a student and a subclass would be a grad student. Okay, so a grad student is a type of student. It's just a little different in terms of, I don't know, whatever grades it might have, how you calculate the grades. So the methods and variables might be a little bit different, but it's very similar to the student, and it is a type of student. Okay, so it's a type of student, but it's a little bit different. Okay, so the way you determine which is subclass and which is superclass is something called an is-a relationship. So, for example, a grad student is a student, but a student is not always a grad student. So many times they will have questions where you have like boxes and they will have different class names and you're supposed to determine the relationship between two classes. And the way you think about it is a relationship. Okay, the next thing we're going to talk about is how exactly to define a subclass within Java. So the first thing you do is to define the class. You would say public class, we'll say just subclass, I don't know what name it is, extends, this keyword is important, super class. So public class, the subclass name extends to superclass, and this would be your heading for the class. Okay, extends is the keyword that tells Java which is a subclass, and it sort of indicates which is going to be the subclass. So it's pretty important, and you would define a subclass the same way you do a superclass in Java in the client program. It's just using the constructors. There are a couple of rules for a subclass. The one is that a subclass inherits all of the methods of the superclass except for the constructors. So keep that in mind. You need to define your own constructors within the subclass, but every other method is already inherited from the superclass. Subclass can add private instance variables to because it's its own class. You can do everything that you want with it. It's just that you cannot modify certain methods in the superclass within a subclass. Just certain methods. There are certain rules there. So a subclass can also add new methods. It can add new methods that do specific things. It can also override inherited methods. So that's something that we're going to be talking about next, which is called method overriding. Subclass cannot override the static methods of the superclass, and then it's a rule within Java. And as I said before, it should define its own constructors. The last rule is that a subclass cannot directly access private data types of the superclass. It needs to use the accessor and mutator methods that we talked about in Unit 3. Okay, so the next thing we're going to do is talk about the super keyword, right? So super is used to call the methods and constructors within a subclass, the superclass method and constructors. So what super does, this default super will call the default constructor of superclass. And super with parameters we'll call the appropriate method. So the appropriate constructor. So remember that there are different types of constructors. So super can be of various types. All right, you can also use super to call specific classes or specific methods of the super class. So if you say super dot method, this could be any method name, you would call that methods. And this is important because in method overriding, when you're modifying methods, many times in the subclass you want to keep the same method, you just want to add a few new details in between, maybe like add stuff to a certain variable or divide a variable at the end. It's very minor changes within the subclass. Okay, and that's what we're going to be talking about next, which is called method overriding. Okay, method overriding is modifying methods from a superclass within a subclass. Taking an example, let's just say calculate grade. Calculate grade is a method. Let's just say it's within the student object, student class. Okay, so calculate grade it does certain things, right? So within a subclass, suppose we create a new method called calculate grade. This is a new method. It's already in the superclass, but we are recreating within the subclass because we want to modify it. Okay, so we'll define a new method called calculate grade. I'm just writing it in pseudocode, not actual code, because, well, it's too long for me to write out. The correct syntax is different. Okay, so calculate grade is its own method within the subclass. And suppose you want to do the same stuff in the superclass that it does in the superclass, except you want to like maybe add 5 points to the grade. So we will just say superclass, or we'll say, sorry, super dot calculate, right? What this does, it calls the superclass calculate grade, which will do whatever it does. It might have some method parameters. It probably will have method parameters, and it does the same thing that the superclass would do. And then maybe you say grade plus equals to 5, right? And maybe that's the difference that it has. Okay, so what have we done here, right? Just looking back, so we created a new method called calculate grade in the subclass, and we called calculate grade of the superclass, and we sort of modified it. And the modification really only occurs in this line. Otherwise, if we didn't want to do that modification, we could just leave it blank. We didn't have to define a new method called calculate grade. We could have just kept it the same, because remember, the subclass already inherits all of the methods from the superclass, so there's no need for this extra modification if you don't have to do it. Okay, so keep that in mind. The next thing that we're going to talk about is polymorphism. Polymorphism seems really complex because it's a tough word, and in my opinion, it's pretty simple. It just builds upon what we learned in method overriding, and it discusses how Java chooses a method to call when you have a class defined in the client program. So all of this stuff over here, inheritance that we talked about, is going on in the back door. Remember, I talked about how to define a class, all of that. So this is what the first part of the unit is going to talk about. Polymorphism occurs in the client program of the method, and when you're calling the method, what exactly is happening. Okay, so the first thing we want to talk about is something called dynamic binding. So what dynamic binding is that dynamic binding just takes, okay, let me discuss it using another example. Okay, so let's say you have a client program, you define a class, whatever, define a method, whatever. There's a client program somewhere, and what you do here is that you have something called student s equals new student. So we're creating a new student object. I'm assuming the student class has a constructor, and now if we call s dot calculate grade, it will call the method calculate grade within the student class, because the type of the object is this first word here. It's a student, right? So it will call calculate grade in the student class. Okay, now if we were to change student to grad student, and this also to grad student, it would call the grad student calculate grade, right? Because now it's defined as grad student, and now it's defined as grad student. Now suppose we make student s equals to, suppose we change it a little bit. We say student s equals to new. Why does my equal sign have 3 lines? I'm dumb. Okay, equals to new grad student. Okay, now what happens? Okay, so student s is the name of the class. What happens when we call s dot calculate grade? Okay, so what it will do is that the first thing it does is at runtime, which means when you click, sorry, at compile time, which means whenever you're running your code, there will be, if you're doing this in BlueJ, notice that there will be a little thing on top that says compiled or compile on the top. So when you click that, it compiles your code. So at compile time, this class is a student. But when you run the code at runtime, it's a grad student. So because at runtime, where you're actually running the code as a grad student, what this code calls is that it will call the get calculate grade method within the grad student class. Okay? So dynamic binding is pretty simple. We also have something called downcasting. Downcasting is where you define a student. Let's say we have student S equals to new student, and we want to convert student S to a grad student. So let's just say we have string X equals to get grade of S dot get grade. But suppose get grade is a method that is only found within the grad student class. So what you would do there is you would change this by saying grad student times S. Or so we'll just say we'll do this here. We'll do grad student S dot get grade. So this is essentially what downcasting is. All that it means is that you are forcibly converting the class S to a grad student through this keyword. Remember in the first unit where we did integer to double conversions and we sort of had that integer thing that happened when you were converting doubles to integers? That's exactly what you're doing here. You're just sort of using the same principle to convert S to a grad student. Okay? And that's pretty much it. I mean, polymorphism and inheritance are it's a fairly basic unit, and there are not likely to be many questions about it on the AP exam. It's a very specific unit, and it's pretty easy to understand. But there's a possibility that there might be maybe one FRQ example about it, and maybe a few MCQs. But it's not like a huge part of the exam. But obviously, still know this very well. It's a pretty important concept just to know in general. Okay. And that's pretty much it. I think we're done with Unit 4. We're pushing along on this APCSA curriculum. Unit 5 is coming up next, which is extremely important. Make sure to watch that. It's arrays, and that is honestly hands down one of the most important concepts in the APCSA curriculum. Okay, that's pretty much it. Make sure to, if you're on my YouTube channel, make sure to go check out my Thinkific course, link down below in the description. If you have any questions or you want to reach out to me, you want to tell me what I should do next, make sure to email me or leave your thoughts in the description box below. Thank you guys for watching. Thank you for supporting me. I'll see you later. Bye.